In our last couple lessons, we've been looking at factoring, specifically trinomials. We talked about simple ones, we talked about complex ones. And today we're going to look at some special cases of those. They might not always look like a trinomial, but they actually are just a weird version. Okay, so we'll pull up our flowchart after and talk about where this is going to fit, but just some big ideas first of all. Okay, so usually we factor our trinomial, and I don't know, we think about man, we had some sort of equation. Let's say x squared and 7x and 12. So we're thinking things that multiply to 12, add to 7. The numbers that we get are what, 3 and 4. And that's kind of our typical question. But sometimes you want to put two brackets that are the same. So for example, we had x squared plus 6x plus 9. Things that multiply and 9 add to 6. What's 3 twice? 3 and 3. If you get that, we can rewrite that as the same bracket twice by putting a squared on it. If that happens, we actually call these things perfect squares. The same bracket twice. Okay. And you can actually recognize a perfect square by the fact that you can square root a and c. And if you do that, and you multiply those numbers together, whatever those happen to be, and then double it, it actually comes out to b. Now, thinking about simple trinomials, man, it's not really a shortcut. It's not really any faster. But thinking about complex ones, super fast. Okay, so keep that in mind for complex ones. When you're done, your answer is going to be one bracket, and inside each bracket is whatever the square root of the first thing is. So in this case, the square root of x squared was x. And the other thing will be the square root of the last term. So the square root of 9 was 3. And we're going to put a squared on it, because the same thing twice. And the sign in the middle could be a plus or minus, depends on whatever b is. Okay. We'll try some just so we get the hang of this. Okay, we'll start with a simple one. It really is just a simple trinomial. Could we find things that multiply to 16 and add to -8? Sure we can. But let's see if we can recognize this new process. So the question I ask myself is, can I square root the first thing? Yes. Can I square root the last thing? Yes. If I take those things, multiply them together, and double it, does it come out to this number? The answer is yes, which tells me this is a perfect square. So how does my answer work? I take the square root of the first thing. I take the square root of the last thing. I say I need two of those. I'm going to double it. And I take the sign of the middle. And there we go. Now, if you didn't remember that and you did this as a simple trinomial, could you figure out the two numbers were -4 and -4? Sure they were. And in fact, if you get the same number twice, it's telling you, hey, it's a perfect square. Now, again, I said simple ones. You can do it as man. You can do it as a perfect square. It's not really a shortcut yet. But take a look at the next one. This looks like a complex trinomial. To do a complex trinomial, I'd have to multiply, add, find my numbers, split it in half, common factor each half, much more steps. But if I notice this time, can I square root the first thing? Yes, square root of 4 is 2. Can I square root the last thing? Yes. That's 6 so far, but if I double that, I get 12. Hey, that's perfect. Which means my brackets, there are two of them. Square root of the first thing, square root of the last thing, sign of the middle thing. Done. Way faster than a complex one. Okay, let's try the next one. Ooh, it looks like a simple one again, but let's see if our shortcut works. Can I square root the first thing? Yes. Can I square root the last thing? Yes. If I double that, what do I get? Ooh, I get 12x, not 13, which means it's not a perfect square, which means I do have to actually do man. It's not always going to work, but we can check for it first. Are there numbers that do this? Sure there are. -9 and -4. Hey, those are different numbers. It's not perfect, which means it's just two separate brackets. Can't forget our old techniques while we're learning new ones. Again, it's a simple trinomial. It might be faster to man. But this one looks like a complex one. Ooh, can I square root this? Yes. Can I square root this? Yes. 3 times 10 is 30. If I double that, I get 60. Perfect. It's a perfect square. So I'm taking my numbers from here. I'm doubling it. And I'm putting a minus sign in because there's a minus sign in the middle. Done. Okay, you guys are going to try a couple real quick. Make sure we got the hang of this. So pause it, try it, see what you get. Can I square root? Can I square root? 5 times 6 is 30. Doubled makes 60. Beautiful. So 5x minus 6 squared. Can I root it? Yep, it's 2. Can I root it? Yeah, it's 3 at 6. Double that, I get 12. Ooh, 12. Not a perfect square. Gotta do this one the long way. Okay, let's man it. Multiply 36. Add to 20. Numbers that do that. I think 18 and 2 work. They're different numbers, that's why it wasn't perfect. Okay, we're going to replace the middle. Sort of splitting this into two parts. And we're literally going to split into two parts. That's a common factor, the first two things. Take out a 2x. This is the idea of grouping here, right? Plus, I have to take something out of here, but they have nothing in common. So here's the one time you can take out the 1. And I know I'm on the right track because my brackets match. So my common bracket and my leftover stuff. And again, we can't forget our old techniques when we're learning new techniques. Okay, take a look at the last one here. Can I square root it? Ooh, no. I can't even square root 2. But before you even start, maybe, hopefully, possibly you noticed these are all even numbers. So shouldn't I common factor first? Isn't that one of our techniques that we've learned about? Divide everything by 2 first, and then maybe you have something nicer. Can I square root x squared now? Sure I can. Can I square root 100? Sure I can. If I double that, 2 times x times 100, that's 20xy. Hey, that's what I got in the middle here. That's perfect. Literally perfect. So the same brackets twice. Okay, sign in the middle. Okay, it's a shortcut. Okay, shortcut if you recognize it. If you don't, do it the long way. It's not a big deal. It's just shortcuts are much faster, more efficient. Okay, the other type of trinomial. As I said, these are all trinomials, but special versions. Well, the other type is what happens when there's no middle term. For example, what if we had this equation? Do we usually write 0x? No, because there's no x's. We usually get rid of that, making it look like this. It looks like there's only 2 terms now, technically because the middle term is 0. When we do this, if we think about it, back to the trinomial idea, and again, they're all just trinomials, what multiplies to -4 and adds to 0? Well, the numbers are 2 and -2, because they have to cancel each other out to make the 0 in the middle, which means we end up with brackets that have the same terms, 2 and 2, they're going to have opposite signs. Okay, we call these binomials, binomial because there's actually only 2 terms, a difference of squares. Okay, you can identify them pretty quickly because, well, there's only 2 terms. You actually have to be able to take the square root of both terms also. And there's always a minus sign. Minus sign because it's a difference. Squares because you can square root them. That's literally what we're going to do here. So our answers are 2 brackets, and they're different brackets, so if that helps you remember the word difference. They're only different because of their signs. One's plus, one's minus. But they literally have the same numbers in both of them. Okay, whatever the square root of the first thing and the last thing are. The one trick with this is sometimes you're going to end up with a bracket that has a minus sign in it, two terms, and things you can further square root. So be careful about this bracket when you're done. Maybe it is another difference of squares. Okay, we're going to try a few here. We're going to make them look like simple trinomials first. Things that multiply to -4 and add to 0. Well, of course, there's numbers that do that. They cancel each other out. They have to be 2 and -2. And we can always do a simple trinomial like that. However, if you recognize that we don't really need to show this term, leaving us with two terms and a minus sign and things I can square root, we can call this a difference of squares. The square root of the first thing, the square root of the last thing, and put different signs between them, which is exactly what this is showing. Just again, for things that are more complicated, a bit of a shortcut. Okay, you guys are going to try this one. Okay, I can think of myself, I don't really need to show this in the middle. So I'm left with two terms, a minus sign, and things I can square root. That means it's the difference of squares. Square root of x squared, square root of 36, 1 plus, 1 minus. The order of your signs don't matter. Notice over here I put plus first, then minus. Here I did the opposite order. It doesn't make a difference which order you put them in. Okay, we're not going to show the 0 in the middle anymore because we don't really need it. It doesn't really make sense to put in there. So can we do these in our new way? Yes. Two terms, minus sign. Can I square root? Yes. So x and 10, x and 10, different signs between. Sometimes people really like the difference of squares because it goes pretty quick once you know your square roots. And that is something you should know how to do. Okay, square root, yes. Square root, yes. Minus sign, of course. Plus and minus. Okay, I'm going to pause. You guys are going to work ahead a little bit here and try these to yourself next. This is where it really gets useful because these are not simple trinomials anymore. This would be a complex one. If I put that 0 back in here, and we know complex ones take some process, right? So a shortcut would be helpful. Okay, can I square root? Yes. Can I square root? Yes. Is there a minus sign? Yes. So I'm going to put different signs. Okay. To do f, same ideas. Can I square root? Yes. Minus sign? Yes. The question usually comes about exponents. When you square root an exponent, you're going to cut it in half. So 3x, well, half of 6 is 3. Okay, square root of 64 is 8, and half of the exponent, 1 plus, 1 minus. That's it, that's all. Okay, last set, x4 minus 1. Well, it's definitely two terms. It's got a minus sign. I can cut it in half. So x and x is going to be squared because half of this. Square root of 1 is actually just 1. 1 plus, 1 minus. Here's where we're going to pause for a second and talk, because if you look at this bracket, it actually meets the conditions of a difference of squares. It's got two terms, it's got a minus sign, and I can square root these things. We haven't talked about this yet, but when you have a difference of squares inside a difference of squares, you got to do it again and split it into two parts. So I'm going to have the square root of x squared is x. The square root of the 1 is 1, 1 plus, 1 minus. This bracket has a plus sign, so nothing can happen with it. We're just going to write it down the way it is. Now you might say to me, well, why did we not do this before? Remember, the big idea is we have to be able to square root something. I can't square root x because it has no exponent. I also can't square root these other ones back here, like this, because you can't break an odd exponent in half. Nor could you have square root 3. So there's lots of little conditions along the way to use these shortcuts. You just have to think about them a little bit. Okay, this one you can stop with. That's as far as you can go. Okay, last two. Let's look for some tricks. Maybe there's some tricks. Can I square root? Yes. Can I square root? Yes. Minus sign? Yes. Okay, let's do it. Split your exponent in half. Okay, I got bracket's got two terms in it. I can square root the 4, but I can't square root of 3. I can't cut that in half. So this one's done. Let's move this one down here just for our last one. Okay, two terms, yes. Minus sign, yes. Can I square root? No. But, again, maybe you recognize or thought to yourself, hey, those are both even numbers. Maybe we should common factor first. Common factoring is a skill that we have to use, or an idea we have to use in every question. Make it easier before you start. You can actually do the math. Now look at this bracket. Two terms, minus sign. Hey, I can square root things this time. The square root of x4 is x squared. Cut it in half. I can square root 625. That makes 25. 1 plus, 1 minus. Oh, look at that last bracket. It has two terms. It's got a minus sign, and I'm pretty sure I can square root 25, so we can do a little bit more. I can't do this bracket. It's got a plus sign in it. But the other one can be split into x plus 5 and x minus 5. And there's your difference of squares. Okay. These shortcuts we've been looking at today help us with more complicated versions of complex trinomials. They are shortcuts, but we want to really tie them back into what we've been doing. We can't forget our quadratic ideas. So here's our last example. Okay, given an equation in standard form, can you remember a couple of our big ideas? Direction of opening. On standard form, that comes from our a value. It's 4, it's a positive, so just remember that's up. Okay, our vertex. Standard form, we had this formula, negative b over 2a. It gives us our AOS, our axis of symmetry. In this case, there is no b value because there's no x term. So we get 0 over 2 times 4, which is just 0. To find our vertex, we're going to take our x value and plug it back into our equation. And hopefully you guys got negative 1. There's our vertex. Why we do this factoring stuff is really for the next question. Standard form is horrible for zeros, but if we can turn into factor form by, I don't know, factoring, then we can find our zeros. So we have to think about this question. It has two terms. It's got a minus sign, and I'm pretty sure we can square root stuff. So I think this is that last idea we talked about, the difference of squares. So 2x and 2x, 1 plus, 1 minus. I want to point out this is factored form. It's not the zeros. We got to figure out the zeros. Looks kind of like a money problem. We have to ask ourselves what makes it equal 0. Well, numbers on one side, letters on the other, divided by 2. And I hope you guys would agree with negative 0.5. We can do the exact same thing with the other one, except for we can cheat because we know the only difference is the signs. So how about 0.5 and 0? And it's positive. And that's why we've been doing this factoring, so we can make factored form. Okay, last part, the y-intercept. Hopefully you recall for y-intercepts that x is always 0. If I put 0 in for x, I end up with negative 1. That's it. Okay, a little bit of practice. Try just A, C's, and E's. Just get the hang of these things. We're looking for shortcuts. If you can't do the shortcuts, it's not the end of the world. Well, for perfect squares at least. Difference of squares, you really want that one. We're going to use that one a lot. But perfect squares, you could always do it as a trinomial if you really had to. Okay, if you're stuck, come see me. Send me a question.